Hello there. I hope all you are feeling good and you are ready to have a good mathematics session. Guys, in this session, we are going to work on solving quadratic equations using completing the square method. Without wasting time, I'm going to give some examples to explain how to use completing the square method. Okay, example. Solve. As first example, I'm going to write this one. Number 1, x squared plus 4x minus 5 equals 0. This is a quadratic equation which is written in its standard form. And if you look at this equation, you can see in this equation the leader coefficient is 1. Let me explain something here. If the leader coefficient is 1, no need to divide terms by the leading coefficient. If the leading coefficient is less than 1, at first step, we should divide all terms by the leader coefficient. In this equation, fortunately, the leader coefficient is 1. Then no need to divide all terms by the leader coefficient. The first step in this equation is keeping the quadratic term. I mean this term, this is the quadratic term, and linear term. This is the linear term in the left side. And moving the constant term, this is the constant term, to the right side. Now we have quadratic term and linear term in the left side and constant in the right side. Now we should turn this left side to an identity of square of a binomial. To turn this part to that identity, we should take coefficient of the linear term, I mean this one, positive 4, and divide it by 2 and raise the result to the power of 2. If inside the parenthesis is simplifiable, simplify that and then raise to the power of 2, which will be 4. Now, after getting this number, we should add up this number to both sides of this equation. After adding up, we can have x squared plus 4x plus 4 equals 5 plus 4. I've added this one to the left and right side. And after this part, you can claim this left side can be turned to an identity of square of a binomial. How? Open a parenthesis and raise the parenthesis to the power of 2. This first term, take this first term and find it is square root. What is the square root of this first term? That is x. Right here as the first term of the binomial. And take this third term and find it is square root. What is the square root of 4? That is 2. Write this one as the second term of the binomial. What about the sign between these two terms? The sign will come from the coefficient of the linear term from here. What is the sign of this coefficient? That's positive. Therefore, you can put here a positive. And you can say expansion of this identity is exactly x squared plus 4x plus 4. Then try to simplify the right side. If you simplify the right side, 5 plus 4 makes 9. As you see, a square is made in the left side. This is the square. Now you can take the square root or the second root from both sides to get rid of this power. If you take second root or square root from the both sides, second root of the left side will be x plus 2. Square root will remove this power. And be sure to put plus minus sign in the right side. Square root of 9 would be 3. As you see, this quadratic equation is separated here to two linear equations. One linear equation with this plus sign, another linear equation with this minus sign. I'm going to write them separately and solve them. X plus 2 equals to 3, the first linear equation, or x plus 2 equals negative 3, the second quadratic equation. Solving the first linear equation will give us x equals 3 minus 2, which will be 1. And solving the second one will give us x equals negative 3 minus 2, which is negative 5. And these are the solutions of this equation, which are found using completing the square method. Let me write one more example from the type in which the leader coefficient is 1. Example number 2. This time, I'm going to solve x squared minus 5x plus 4 equals 0. Again, as you see in this equation, the leading coefficient here is 1. No need to divide all terms by the leading coefficient. Then keep the quadratic term and linear term in the left side. This is the quadratic term and this one is the linear term. I kept them in left side and I want to move 4 to the right side. If you move 4 to the right side, you will have negative 4. At this step, you should take coefficient of the linear term and divide it by 2, then raise the result to the power of 2. And since inside the parentheses is not simplifiable more, raise the top and bottom to the power of 4. This way you can have 25 over 4. And then add this number to both sides of this equation. X squared minus 5x plus 25 over 4, which is added to the left, minus 4 plus 25 over 4. As I did in first example, this left side can turn to an identity. Put a parenthesis here, raise it to the power of 2. Square root of first term will come here as the first term. Square root of this added number, or let me say the third term, will come here. It is the square root is 5 over 2. And sign will come from this one. What is the sign of this? That is negative. Okay, between x and negative 5 over 2, we should put negative sign. Expansion of this identity is exactly this trinomial. And then we should simplify the right side. In the right side, we have an integer and a fraction. To simplify the right side, you can give a denominator of 1 for negative 4, and then to make denominators the same, multiply this one and this one by 4 to have the same denominators. In this way, the common denominator will be 4, and on the top we can have negative 16 plus 25. And if you simplify this fraction a little more, you will reach to 9 over 4. Now that is time to take square root from both sides. Taking square root from left side will result in x minus 5 over 2 equals to, don't forget to put plus minus sign, square root of 9 is 3 and square root of 4 is 2. Again, you can see our quadratic equation, this one, has separated to two different linear equations. We should solve them separately, one by one. Once I'm going to put x minus 5 over 2 equals 3 over 2. The other time, x minus 5 over 2 equals to negative 3 over 2. Solving the first one will result in x equals to 3 over 2 plus 5 over 2, which will be 8 over 2, which will simplify to 4. And solving the second one will result in x equals negative 3 over 2 plus 5 over 2, which will turn to 2 over 2, which is equal to 5. And these are solutions of this quadratic equation, which is found using completing the square method. Now, We are going to try the equations in them. The leading coefficient is not 1. Let me write one of those type of questions. Number 3. Example number 3. Suppose this equation is given 2x squared minus 3x plus 1 equals 0. Okay, guys. As you see in this equation, the leading coefficient here is not 1. Therefore, at first step, we should divide all terms by 2. Okay, dividing all terms by 2 will result in x squared minus 3 over 2x plus 1 over 2 equals 0. Now we can keep quadratic term, which is x squared, and linear term, which is negative 3 over 2x in the left side, and move this constant to the right side. If you move it to the right side, you will have negative 1 over 2. Then take the coefficient of linear term, which is negative 3 over 2, divide it by 2, raise the result to the power of 2. In this parentheses, as you see, we have a fraction over an integer. I'm going to give a denominator of 1 to this integer, and now you can do far to far, near to near to simplify this one. If you do far to far, I mean these two with each other and these two with each other. 1 times negative 3 will make negative 3, and 2 times 2 will make 4, whole to the power of 2. And the result will be 9 over 16. Now we can add this pound number to the both sides. Let me add it to the both sides. X squared minus 3 over 2x plus 9 over 16 equals to negative 1 over 2 plus 9 over 16. Okay, guys, these three terms in the left side will turn to an identity. Which identity? Put a parenthesis which is raised to the power of 2 in the left side. Write square root of this first term as the first term inside this parenthesis, and square root of this third term, or the added number, which is 3 over 4, as the second term of this binomial. And sign from here, from this one, will come to here. What is the sign? That is negative. Then put negative sign here. Expansion of this identity is exactly this trinomial. And after doing this, simplify the right side. To simplify the right side, you see we are faced with two fractions. They don't have the same denominators. Then, first of all, we should turn denominators to the same. To do that, it is better to multiply denominator and numerator of the first fraction by 8. In this way, we can have negative 8 from here, plus 9 over 16. 16 works as common denominator. And if you simplify a little more, that will be 1 over 16. Now you can take square root from both sides. If you take square root from both sides, you can have x minus 3 over 4 square root of the left side is equal to, don't forget to put plus minus sign, square root of 1 is 1, square root of 16 is 4. Okay, again, we have two linear equations, two different linear equations. I'm going to solve them separately. X minus 3 over 4 equals 1 over 4, or x minus 3 over 4 equals to negative 1 over 4. Solving the first one will result in x equals 1 over 4 plus 3 over 4, which is 4 over 4, which is 1. And solving the second one will result in x equals negative 1 over 4 plus 3 over 4, which is 2 over 4, or you can write 1 over 2. These are the solutions. This is the way to solve the quadratic equations. In them, the leading coefficient or the leader coefficient is not 1. I'm going to do one more example of this type to be much familiar with this type of equations. Number 4. Suppose in this equation we have negative 3x squared plus 5x minus 2 equals 0. Okay, guys, as you see the leading coefficient is not 1, then divide all the terms by the leading coefficient, divide them by negative 3. If you divide them by negative 3, you will have x squared minus 5 over 3x plus 2 over 3 is equal to 0. And from here, you can say, okay, I'm going to keep the quadratic term and linear term in the left side. And I want to move the constant to the right side. If I move the constant term to the right side, that will turn to negative 2 over 3. Take coefficient of the linear term, negative 5 over 3. Divide it by 2. Raise the whole to the power of 2. A fraction is divided by an integer. Give a denominator of 1 to this integer at the denominator, and then do far to far, near to near. Doing far to far, near to near will result in negative 5 over 6 whole to the power of 2. And then raise the result to the power of 2, 25 over 36. This number, which is found here, should be added to the both sides of this equation. Let us add that number to the both sides of the equation. X squared minus 5 over 3x plus 25 over 36 would be equal to negative 2 over 3 plus 25 over 36. As I explained in examples above, these three terms will turn to an identity of square of a binomial. The square root of this first term will come here as the first term of the binomial, and the square root of this third term will come here as second term of the binomial, and the sign between these two will come from this number, coefficient of the middle term, linear term, that is negative. And then try to simplify the right side. In simplifying right side, you will see you are faced with two fractions with different denominators. Try to make their denominators the same. To do that, multiply denominator and numerator of the first fraction by 12. In this way, you can have common denominator of 36, and in the numerator, negative 24. Negative 2 times 12 makes this negative 24 plus 25. And if you simplify this fraction a little more, you can have 1 over 36. Okay, guys, now that is time to take a square root from both sides. Square root of the left side will give us x minus 5 over 6, which is equal to, again, I'm emphasizing, don't forget to put plus minus sign. Square root of 1 is 1, square root of 36 is 6. Now, we are faced with two different linear equations. I'm going to do or solve them one by one. X minus 5 over 6 once will be equal to 1 over 6, and the other time it will be equal to x minus 5 over 6 equals to negative 1 over 6. Solving the first one will result in x equals 1 over 6 plus 5 over 6, which is 6 over 6 or 1, and solving the next one will result in x equals negative 1 over 6 plus 5 over 6, which is equal to 4 over 6 or 2 over 3. These are the solutions of this equation. We found them using completing the square method. Sometimes in some equations we will face, uh, sometimes in some equations the constant won't be available. For example, like this one, 3x squared minus 5x equals 0. In this equation, leader coefficient is 3 and constant term is not available. To solve this type of equations, at first step, divide all terms by the leader coefficient. This way you will have x2 minus 5 over 3, x equals 0. And since there is not any constant term, no need to move the constant term to the other side because it is not available. Then take the coefficient of the linear term and divide it by 2. Raise the result to the power of 2. Give a denominator of 1 to this one. Do far to far, near to near. Negative 5 over 6 whole to the power of 2. Raise both sides to the power of 2. You can have 25 over 36. Then add this number to the both sides. X squared minus 5 over 3. X plus 25 over 36 equals 0 plus 25 over 36. The left side will turn to an identity. Which identity? This one. Put a parenthesis and raise it to the power of 2. Square root of this will come here as the first term of the identity, and square root of this will come here as the second term of the identity, and the sign will come from this one. And simplify the right side. The right side will be 25 over 36. Then you can take square root. If you take square root, you will have x minus 5 over 6 is equal to plus minus. Don't forget, please, to put this plus minus sign. 5 over 6. And then you can say I have two linear equations which should be solved. X minus 5 over 6 equals 5 over 6, or x minus 5 over 6 equals to negative 5 over 6. Solving the first one will result in x equals 5 over 6 plus 5 over 6, which is 10 over 6 or 5 over 3. And solving the second one will result in x equals negative 5 over 6 plus 5 over 6. I brought this negative 5 over 6 to the right side. This sign changed to positive. And as you see, these two fractions are opposite of each other. Then their answer will be 0. And these are the solutions of these equations. Okay, guys. Till now, we solved 5 equations and we got their solutions. But sometimes in solving quadratic equations, we will face with the cases in them quadratic equation doesn't have any solution or has just one solution. Those type will be explained in the next session. Wait for our next session. Have a nice time. Bye-bye.